Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm gonna talk about differential calculus and its application in real life. So we have a question here and it's about pump house. So that needs to be placed at some point X along a river. So then two pipelines will be connected to the from pump house to homes. So one pipeline and another one. So we do have household at A and household at B. So what we need to find out, how far should point X be from M so that the total length of pipeline is minimized, so that this length AX plus XB is minimized. So we have an option of this pump house to be here or there or here, but what we need to find is how far it should be from M in order to minimize the pipeline. So pretty much the first step it would be to find this length AX and XB because it's not given. So to find that line, the total length, and in order to find when it's minimized or maximized, pretty much I'll be looking to find the first derivative. So because first derivative equal to 0 is going to give us minimum or the maximum of that function. So let's start. How are we going to find AX? So in order to find AX, we're going to see if we do have anything given. So we can see that length AM is 2 kilometers. MX it's not given. So what we're going to do, we're going to say that, okay, M of X is going to be labeled like small x. So that's going to be the length of MX. And if all this length M to N is 5 and M to X is X, small x, then all we're saying that X to N, this part here is 5 take away X. Now using Pythagoras, because we can see that here we do have right angle triangle, using Pythagoras, so we can find this length from A to X. So we're going to find the length AX. So I'm going to do here, okay, AX to the power of 2 is equal to the other two sides, 2 to the power of 2 plus X to the power of 2. And from here, I'm just going to square root both sides, and we're going to have AX is equal to 2 to the power of 2 plus X to the power of 2. Or I'm going to replace this 2 to the power of 2 by 4, this one here, or I'm just going to leave it, that's fine. So which is equal to 4 plus X to the power of 2. Please note that I don't have plus minus here, so I'm going to get rid of that. I don't have it, as I'm going to say here on the side that AX is bigger than 0. So which means I just need the positive sign. Now we have AX, beautiful. So AX has been calculated. So is this part here. So let's find now BX. In similar way, we're going to find BX, and it's going to be equal to what? BX, everything to the power of 2, is equal to, so I can actually, have line here saying that the distance AX and BX is equal to sum of the other two sides to the power of 2, 1 to the power of 2 plus, and the other side here is 5 take away X. So it's 5 take away X and everything to the power of 2. From here, BX length is, let's go like length is equal to square root of 1 plus. And now we can actually expand this part here straight away. So we're going to go with let's use green. It's going to be what? 25 take away 10x and plus x to the power of 2. I'm just using the rule for expanding our perfect square. This can be simplified a little bit. So I'm going to go therefore Therefore, length bx is equal to, let's put in order of x to the power of 2, take away 10x, and 1 plus 25 is 26, so it's going to be plus 26. So we do have two lengths, so we have bx here, and a of x is here. So now how far, so to looking for the total length. So the next step, it will be to find the total length. So length is equal to ax plus bx. So which is equal to, what is ax? Is square root of 4 plus x to the power of 2, and plus bx is x to the power of 2, take away 10x, and then plus 26. Now, so we do have the total length, but we have to find where this x should be from m, so that the total length of pipeline is minimized. So pi is minimized. And as I mentioned before, in order to find minimum, maximum, we're looking at the first derivative. So let's find first derivative. And I'm just going to go next page now and to the beginning on page 1. So, and we have a look here that the maximum length here is 5. So this x can't be bigger than 5. So x has to be less or equal to 5. So again, to x, this x here should be from m 3 kilometers and 1/3. Did we use kilometers? Yes. So write this equation. L is equal to square root of 4 plus x to the power of 2 plus, I think it's 10x, no, it's x. Okay, just get, it is x to the power of 2, take away 10x, and plus 26. Yes, that's what it is. Let's find first derivative. But before we find first derivative, I'm gonna write this in index form. So because we do know the rules that we need to apply to find first derivative. So that's L. Now let's do first derivative in blue. So dl to differentiate L with respect to x, and it's going to be this. The first thing is we're going to apply chain rule. So looking here at this, power chain rule, half power goes in front of the brackets. We copy whatever is inside, which is 4 plus x to the power of 2. This power here is going to decrease by 1. Half take away 1 is negative half. And now we have to differentiate whatever it's inside. So derivative of 4 is 0, and derivative of x to the power of 2 is 2x. So it's times 2x. So the first part of the equation is done. Let's now focus at the second part. Similar, we're going to take half in front of the brackets, copy everything that we have inside the brackets, and then reduce this power by 1. So half take away 1 is negative half, and now find the derivative of what is inside. So derivative of x to the power of 2 is 2x, derivative of negative 10x is negative 10, derivative of 26 is 0. So it's not going to read that. Write that. So let's rephrase this, rewrite this a little bit. 2 and 2 can be cancelled out, so that is good. What we can do here, this part here, 2x take away 10. Okay, let's, next line, let's rewrite this. So what's left here in numerator is x, and I'm going to move the part here that has negative power, negative half. I'm going to move into denominator, so the power is going to become positive. So this is going to be 4 plus x to the power of 2 to the power of half. So, and then plus, we still have here 2x take away 10 over 2 times, and same, similar what we did before. This part here, because it has negative power, we're going to move into denominator and it's going to change the power to positive. So that will be x to the power of 2 take away 10x plus 26 and everything to power of half. So let's go next one. Okay, so it's x. Now this part here, this one to the power of half is exactly the same as 4 plus x to the power of 2 plus. What I'm going to do here, I'm going to take 2 in front of the brackets, so it's going to be 2. Okay, let's go 2. Yeah, that's fine. Take 2, and we're going to be left x take away 5 over 2. Rewrite this part here with the square root. That's going to become this x to the power of 2 take away 10x plus 26. Okay, beautiful. And we can cancel 2 and 2. Now, in order to find minimum or maximum, so the first derivative needs to be equal to 0. So all of this needs to be equal to 0. So, and we do know when it's going to be equal to 0, when numerator is equal to 0. So pretty much what I'm going to do next is sort of tidy up this part here a little bit. So what I'm going to do is actually, I'm going to do this, like I'm going to put 4 plus x to the power of 2 and move all of this to the other side, which becomes negative x take away 5 over all of this x to the power of 2 take away 10x and then plus 26. So it does look a little bit nasty, but that is fine. Before I move on, there's one more thing that I may apply here, and I'm going to write this on the side here. So I have negative here, negative, we have negative x take away 5. So what we can do here, we can actually have this negative and then take negative from here, from inside. So take negative out. So this x is going to become negative x, and negative 5 is going to become positive 5. So negative and negative next to each other is positive, and this just looks a bit weird. So I'm just going to rewrite like 5 take away x. So pretty much what I did here is just I got rid of negative sign, so like it's just neater. So and it gave us 5 take away x. So all of this now is actually 5 take away x. So the next step that I'm going to do is cross multiplication. Like that, okay? Cross multiplication. So that will give me, okay, next line, let's have a look. So cross multiplication. It's going to be x times all of that x to the power of 2 take away 10x plus 26 equal to, now 5 take away x and times 4 plus x to the power of 2. It does look a little bit nasty with these, you know, square roots. So but we do know when we like want to get rid of square roots, so we actually put everything to the power of 2. So we're going to do that. Now, everything to the power of 2, both sides, everything to the power of 2. So whatever we do on one side, we have to apply to the other side as well. So now this is going to give us now this. So next one, okay, plus just have a look page before. Yep, if we go, let's go back. So what we have, I'm just going to rewrite one more time. So it's x square root x to the power of 2 take away 10x plus 26, everything to the power of 2. So we had that line just before, but I'm just going to rewrite it one more time. And then all of this and everything to the power of 2. Now what's happening here, it's pretty much that everything inside is going to be to the power of 2. So x to the power of 2, every single term. And then this bit here is 10, all of that, and that's to the power of 2 as well. So we're applying index law. 5 take away x, everything to the power of 2, and 4 plus x to the power of 2, everything to the power of 2. So what's gonna happen, this power and this is gonna cancel out, this and this is gonna cancel out. So we're gonna be left with x to the power of 2 times x to the power of 2 take away 10x and plus 26 equal to, we can expand this part here, which is going to be 25 take away 10x and plus x to the power of 2, and then times 4 plus x to the power of 2. Now the next line, it would be to expand, to multiply every single term inside the brackets with whatever we have in front of the brackets. So that would give us x to the power of 4 take away 10x to the power of 3 plus 26x to the power of 2 equal to, so 25 times 4, 4 times this, and yep, so it's going to give us 100 take away 40x plus 4x to the power of 2. And now we do the same with x to the power of 2, which is plus 25x to the power of 2. And then x to the power of 2 times negative 10x is negative 10x to the power of 3. And x to the power of 2 times x to the power of 2 is plus x to the power of 4. Now we're going to have a look if we can cancel out anything. So on one side we had positive x to the power of 4. So it's this one here. And we have positive x to the power of 4 as well. So we can cross that out. So it's gone. Also, we have negative 10x to the power of 3, negative 10x to the power of 3. That is gone as well. So, and now let's collect some terms. So, I'm still going to go here. 26x to the power of 2 equal to 100. Let's put together negative 40x. 4x to the power of 2 plus 25x is plus 29x to the power of 2. Let's move everything to one side. So I'm going to move this to the other side, and it's going to become, it's like take away. Okay, let's use different color. It's like take away 26x on both sides, 26x to the power of 2 on both sides. So it's going to give us 0. So it's 0 equal to 100 take away 40x. 29x to the power of 2 take away 26x to the power of 2 is plus 3x to the power of 2. This is the same if you write like this. So it's the same. Now, we can solve this using, factorization, quadratic formula. So, but what I'm going to do, I'm just going to use graphics calculator. So use graphics calculator, and it does give me two solutions. So one, it's 10 over 3, and another one is x equal to 10. Now, x equal to 10 can't be used, so I'm going to cross out this one here. And the reason, so it can't be definitely 10. So x has to be less or equal to 5, even smaller than 5. If it's 5, then it's going to be equal to, there won't be length. So, but it can't be 10. So therefore, x is equal to 10 over 3, which is the same as 3 over 1/3 kilometers. So we do have, where x should be from m. So x should be, so that is the one. Okay, so this is this one here. Let's circle that one. Okay, now we already know that this should be, the minimums to give us the minimum. But what I'm gonna do next is actually to use sign diagram, just to make sure this one give us minimum. So sign diagram. When x is equal to 10 over 3, sign diagram, x minimum 0, can't be bigger than 5, so it's 10 over 3. So if I choose a value of x less than 10 over 3, here it could be 2. So the first derivative, dl dx, here is going to be negative, so you can check that, should give you negative answer. So, and here we're going to have positive. So So which means the graph is gonna go like this. So we're gonna have our minimum. So what we can say here, the minimum length, the minimum length of pipeline occur when x is equal to 10 over 3 kilometers. So pretty much what we're saying that x should be 10 over 3 kilometers. X should be 10/3 kilometers away of m to minimize the length of the pipeline. So you may think like, oh, who cares, it's going to be the minimum or whatever, but sometimes we use very expensive material, and we really don't want to waste material and money as well. So we're looking what is the minimum that's going to be needed. I hope this is going to help you in any way. So thank you for watching and talk to you soon. Bye.